this was going to happen.
Hey guys, so we are going to keep on moving along in chapter 5. We're going to move on to lesson 5.2. So let me present my screen and we'll get started.
This is exactly what happened. They're pushing back.
Share. All right, so 5.2, we're going to be talking about congruent triangles in this lesson. All right, so first we have a theorem. It's called the third angle theorem. This just kind of logically makes sense. So think about it. Don't overthink it. It just says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So what that means is if you have two triangles, and angle B is congruent to angle E, and angle A is congruent to angle D, then angles C and F are going to have to be congruent to each other. And you can make up like angle measurements to illustrate this to understand a little better. Like let's say, oops, sorry, ignore that. Let's say that this angle is, we'll just say that that's 80. That means that E would have to be 80. Let's say that this is 50. This angle would also have to be 50. So because the three angles of a triangle have to add up to 180, all right, you'd add the 2 and subtract from 180 and get that C is 50. Add the 2, subtract from 180 and get that F is 50. So C and F are going to have to be congruent. Okay, that's all that third angle theorem says. All right, moving on down. We're going to get actually right into some practice problems. All right, it says in exercises 1 and 2, identify all pairs of congruent corresponding parts, then write another congruency statement for each polygon. So you're told that the triangles are congruent, and the order in which the letters is given is super important, because even if the diagrams weren't given, just based on the order of the letters, P and S are congruent to each other. What I mean by that is angle P is congruent to angle S, angle Q is congruent to angle T, angle R is congruent to angle U. Side PQ is congruent to side SU, side QR is congruent to side TU, side PR is congruent to side SU. Okay, and you can look at the markings as well. R has one angle marking, U has one angle marking, Q has two angle markings, T has two angle markings, and then P and S have the same angle markings. So identifying the pairs of congruent corresponding pieces, we're going to have three angles. So you're going to say that angle P is congruent to angle S, right? Angle P is congruent to angle S. Angle Q is congruent to angle T, again, because it's second letter, but also looking at the diagram, Q has two arcs and T has two arcs. And then finally, angle R is congruent to angle U. All right, then we have to go through and name all the corresponding congruent sides. So this side right here, actually, yeah, I want to go in that order. PQ, all right. If you look at the diagram, think about going from P that has three angle markings and Q that has two angle markings. So that side matches up to this side here. But also first and second letter, right? PQ and ST. So we can say that segment PQ is congruent to segment ST. And now I'm going to either look at the diagram. I guess I'll look at the diagram. So I'm going to go QR, so two arcs to one arc. So I'm looking for the side that connects the two arcs and the one arc, this one here. Okay, so those two sides are corresponding and they're congruent. QR, the second and third letter, is going to be congruent to ST, second and third letter. So QR is congruent to TU. And then finally, we're going to look at PR, all right, from one arc to three arcs, and US, one arc to three arcs, first and last letter. So PR is congruent to SU. All right, when you name the triangles, you want to name them so that corresponding pieces match up like they were named in the first one. So if I change the order of the triangle, the letters of the triangle, so let's say, for instance, I call this triangle QRP, then I need to change the order of the letters in the next triangle so that they still match. So since Q corresponds to T and R corresponds to U, and P corresponds to S, I have to call it TUS, all right? Or you could call it like PRQ is congruent to triangle SUT. So there's lots of different options on how to name the triangles. What's important is once you name the first triangle, you have to make sure that the corresponding pieces match in the second triangle, okay? All right, so that's the first example. Second example is same idea. Again, you don't even need to look at the diagrams. You can just look at the order of the letters. So very quickly, just looking at the order of the letters, I know that angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. The sides that match up, first and second letter, then second and third, and so on and so forth. So it would be side AB is congruent to side EF. Then I would say that side BC is congruent to side FG. Side CD is congruent to side GH. And then side AD is congruent to side EH. All right. And you could again go around and mark. Okay. If you look for, let's start with 1 arc, 2 arcs, mark that one congruent to this side here. They match up. Then 2 arcs to 3 arcs, 2 arcs to 3 arcs. So these two sides match up. Then these two sides match up. And finally, those sides match up. Okay. Naming the polygon. Again, you don't even have to look at the diagrams. Just go second, third, fourth, first. Second, third, fourth, first, and reorder the letters. So you could say A, C, D. Sorry, I said the wrong letter, but wrote what I meant. Let's try that again. You could say B, C, D, A is congruent to F, G, H, E. Okay, that's just one example. I could have just gone in the backwards order, right? I could call it DCBA is congruent to HGFE. So we could all be naming it differently, but based on how you name the first figure, you have to make sure that the corresponding parts match in the second figure. Okay? All right, let's keep on moving along. For 3 and 4, it says find the values of X and Y. So we're going to look for corresponding parts that match up, right? And then we're going to set things equal to each other that are supposed to be equal. So based on the fact that, let me get my pen, there we go. You have 1 tick mark on XZ and 1 tick mark on ST. That means that they're congruent to each other. So you can say that 3Y plus 9 has to equal 15. And that's because ST is equal to XZ. Okay, and then you can solve for Y. So I'm going to subtract 9 from both sides. So I'm going to have 3Y equals 6, divide both sides by 3, and you get Y is equal to 2. Okay, and then angle S, look at the letter order in the name. Angle S, middle letter, angle Y, middle letter. Those two angles are congruent to each other. So that means that the measurement of angle Y is equal to the measurement of angle S. So you're going to say that 2x minus 20 is equal to 30. Add the 20 to both sides. So 2x is equal to 50. Divide by 2. X is equal to 25. All right. Let's move on to the next one. So angle A, this angle here, first letter, matches up with angle E, this letter here. So I know the measurement of angle A is equal to the measurement of angle E. So I can set them equal to each other. Let me erase because I can't see what it says. So angle A is 60 plus 8x. Angle E is 108. Oh, that's an ugly 8. Subtract 60 from both sides. So you have 8x is equal to 48. Divide both sides by 8, and x is equal to 6. All right. Okay, and then angle C, that third letter, matches up with G, the third letter. So angle C matches up with angle G. So you can set them equal to each other. The measurement of angle C equals the measurement of angle G. So I can say that 62, I think that was a 62. Erase, yep. 62 is equal to 8y minus 3x. Okay, well, this has two variables, but luckily I already solved for x before. If I had set this equation up first, I might have to go and figure out x and then come back here, okay? But I already have x. So I'm going to substitute the x in, which is a 6. All right, then I'm going to do the multiplication, 8y minus 18. Add 18 to both sides, so 80 equals 8y. Divide both sides by 8, and you get y is equal to 10. Ran out of room down there. All right. Okay, let's keep on moving along. In exercises 5 and 6, it says show that the polygons are congruent. Explain your reasoning. So in order to show that the polygons are congruent, we want to show that all corresponding pieces are congruent. So I want to show that all 3 angles are congruent and all 3 sides are congruent. Okay, so for number 5, I have marked. Okay, so it's basically given information since it's marked. You know that side AD is congruent to side DC. And I'm just going to write given kind of as my justification. That's given in the diagram. I also know that BC, this side here, is marked congruent to BA. That's also given information, right? It was marked in the diagram. How do I know that BD is congruent to BD? Isn't BD, this segment here, part of both triangles? Like envision if you were to slide them apart, pull them apart, they both have a BD, right, as one of the sides of the triangle. So it's congruent to itself using which property? Remember what property that was? That's the reflexive property. So I know that all 3 sides are congruent. Now let's talk about the angles. Again, given information, I know that angle A is congruent to angle C because it's marked. I guess I'll do my angles up here. So angle A is congruent to angle C. That's given. Okay, what else do I know? Well, if this is a right angle, doesn't the one right next door have to be a right angle since they're a linear pair? Okay, or we haven't really talked too much about perpendicular lines yet, but if you have perpendicular lines and that creates congruent adjacent angles, so those 2 angles are going to be equal to each other. For now, we'll just say that that's given. Okay, we won't get too specific about that. So we're going to say that angle ADB, this one that was given as 90, is congruent to angle CDB. And again, just for now, because this isn't a true proof, we're just going to say given, although we'd want to say that perpendicular lines implies congruent adjacent angles, or maybe you'd want to use some kind of linear pair postulate to get there. All right, and then finally, how do I know that angle DBA, this angle right here, how do I know that that angle is congruent to this one? By the third angle theorem, the one that we talked about today, right? That if 2 angles of one triangle are congruent to 2 angles of the other, the third angles have to be congruent. So now I can say that angle ABD is congruent to angle CBD, and that's by the third angle theorem. All right. And finally, because all the angles are congruent to each other and all the sides, all the corresponding sides are congruent to each other, you can say that triangle ABD is congruent, and be careful how you name the second triangle, it has to be consistent. So I'd have to name the other one CBD. And I'll just say because all corresponding parts are congruent. Because all the corresponding parts are congruent, that makes the triangles congruent. All right. Okay. Number 6 is similar in that we're going to name all of, or I guess we're not even going to name them. I'm not going to write them all down. You can see angle I is congruent to angle M, angle L is congruent to angle H, angle N and G, K and J. They're all 90-degree angles. And you can see the sides that are marked congruent to each other. So what I'm going to do is I'm going to name the first one and give you a minute to make sure that you can name the second one correctly. So if I name the first one, oh, I didn't mean to put a line there. Erase that. There's going to be a line where you're going to give me the answer. So if I name the first one L, M, N, K, tell me what that's congruent to. So pause the video if you need to, because I'm not going to wait too long. Pause the video and look to see what angle does L match up with. Matches with H. Then I go to M. M matches with, so it goes from H to I. And then from I, you'd have to keep going around, right, to close the figure. So it would be J and then G, okay? All right, the last two problems. In exercises 7 and 8, find the measurement of angle 1. All right, let's look at 8 first because it's a little bit of an easier diagram to look at, and then we'll go back to 7. So for number 8, don't forget things that we've learned in the past, your vertical angles. Vertical angles are congruent to this angle down here is 54, okay? I have angle 1 marked congruent to this angle down here, which means that if I have two angles, meaning this angle and this angle, congruent to two angles, meaning this angle and this angle, wouldn't the third angles have to be congruent? So I know that this angle has to be 80 degrees because of that third angle theorem, all right? So whether you look at this triangle or this one, it doesn't matter, but you know that the three angles add up to 180. So you can say the measurement of angle 1 plus 54 plus 80 have to add up to 180 because the three angles of a triangle add up to 180, okay? So we're gonna subtract 80 from both sides. The measurement of angle 1 plus 54 equals 100. Get 100. And then you're going to subtract 54 from both sides, and you're left with the measurement of angle 1 equals 46 degrees. All right. All right, so for this diagram down here, it's a little more complicated. There's a little bit more going on. We have lots of different triangles that we could be looking at. You could be looking at this, I'll trace it for now, this right triangle here. That's one, that right triangle there. You could be looking at this triangle here. Okay, that's also a right triangle. You might want to look at this triangle right here. It's another triangle that we might need to look at. Two more. So I could be focusing on this triangle here and or this triangle here. Okay, so lots of things to think about for this diagram. All right, so since this angle is marked as 30 degrees, this angle is congruent to that 33 degree angle. So I can mark that angle as 33 degrees as well, okay? From there, we could figure out, since this is a 90-degree angle here, okay, these three angles right down here have to add up to 180. So if I subtract, I'm going to get 50, I can't write it, 57 degrees. All right. Now, if I look at this 90-degree angle, the measurement of angle 1 plus that 57-degree angle have to add up to give you that 90 degrees. So now I can just subtract 57 from both sides, and you're left with the measurement of angle 1 equals 33 degrees. Okay, sometimes overlapping triangles are hard, and might be helpful to kind of redraw the diagram separating the triangles. That sometimes can be helpful, but hopefully you guys followed along with that one. All right, guys, that is it, I believe, for this lesson. Let me just take a quick look. yeah, there's some extra practice problems that we're not going to spend time doing during our video notes, but feel free to do them as extra practice. And if you're ever looking for extra practice, you can always jump onto a 12th period meet to ask for help with those if you need some help. Okay. All right. So that is it for lesson 5.2. I'll see you back here for 5.3. Bye.